Hey guys, so I made some changes to the GraphQL boilerplate, and the changes that I made were related to how we generate the GraphQL schema. So I wanted to share with you guys what I changed and why I changed it. So first off, I wanted to go over real quickly what it looked like before. So here's how we did it. We would look for a folder called modules. So we would read in all the folders inside of the modules folder, which here's what our module folder looks like. So we have, each one is sectioned to like its own little chunk or unit, and it would either be like a mutation in there or a piece of code. So like register would have all the stuff we need to do to register a user. And so one problem emerged immediately, and that is, look at all these folders. I've only done a small part, so this is only covering the user, and I already have this many folders. So as I add more and more things to the boilerplate, this module folder is going to kind of expand and grow, and I need to nest it more so it's not just like a flat output of a ton of files or a bunch of folders. And that's kind of where our generate schema breaks down, because we assume a certain format for the folder structure, right? So I would just basically linearly go down the modules, and for each module I would import the resolvers, and then I import the type defs, and then I would create a schema out of that, and then I would have a bunch of schemas, and then I would merge all the schemas. So that was the first problem. So just that the structure would not, I need to change how I want my folder structure. So generate schema is not flexible enough right now to where if I change my folder structure, I also need to change generate schema. And so I wanted to set up generate schema to where no matter how I set up my modules, or no matter where my GraphQL code is, I don't have to change how I generate the schema. The other thing that I wanted to change is how I did read in the schema a little bit. So right now, because we're using GraphQL tools to merge the schemas, and there's a bug in it, I had to set up kind of like a stub or a dummy query. So that's kind of annoying. I could just wait for GraphQL tools to upgrade their code and to get rid of that bug, but I was like, I didn't want to wait. The other thing is this import statement at the top. Now, this is something that could go either way. But for me, I would prefer not to have to import every single type that I'm using globally. Now, on the other hand, it may not be as clear, like for example, where this error type is coming from if this is not included. But in general, I kind of like cleaning up the schema. So, and there's three things basically that we're going to be fixing: not having to put a stub type, not having to import types that you're using from other files, and then lastly, being able to import the GraphQL and the resolvers no matter how I change the folder structure here. So here is what I changed generate schema to handle all of those things. So first off, I just create a string right here, and this is just the path to the modules. And I'm using a library called glob, and what glob does is kind of like the Unix star pattern. It lets you use that to basically find files. So here I am synchronously doing this because I said glob.sync, and I'm looking for all of the modules or all the things inside of modules that fit this pattern. And the pattern that I used was star star and then a slash and then star.graphql. So what this does is it goes any number of folders deep. That's what double star does. So it looks through all the folders, and then if there's nested folders, it goes recursively deep in there. And it looks for any files that have the type .graphql. So it doesn't matter what it's called, it looks for them. So this basically finds all of the GraphQL files, right? So this solves our problem of maybe I change where I'm putting folders. Doesn't matter, because this is going to look through all of them basically for all the GraphQLs. And then I'm just, for each file that I find, so for each GraphQL file I find, I am reading in the file. Now you'll notice I'm using fs, just like reading the file in as a string. Now just side note real quick, make sure you use encoding UTF-8 if you do this, because it will read in as a buffer otherwise. But this will give me a string of the schema. Now the reason why I'm wanting a string instead of, for example, using GraphQL import, which is what we were using before, so we're using the import schema. One downside to import schema is it validates your schema. So when it would read in this GraphQL file, it would validate all the types are there. So if I get rid of this import statement here, this is not a valid schema in the eyes of GraphQL import, because it doesn't know where this error type is coming from. You need to have this import, and because I didn't want to add that import, I just read it in as a string instead. So what this will give me now is an array of strings, and so each item in the array is a GraphQL type. So I just have an array of all the GraphQL types in my project. And then there is a library called Merge GraphQL Schemas that works a lot better, or at least it doesn't have any problems with merging them, at least so far that I've used them for. And we just merge them all together and we pass that into the type defs for making an executable schema. So then I'm doing the exact same thing for the resolvers as well, and they have a merge resolvers from this library too. And so I glob sync, and then here the pattern is ** again, so I'm looking any number of folders deep, and then I'm looking for a file called resolvers. Now this might be interesting. I did a question mark here s. So a lot of you may think you might just do like resolvers.ts, right? And that's actually what I had at first. But then when it came to compiling the code, it would generate all JavaScript files. So then when it would use this glob statement, it was not able to find the resolvers. So instead I use this question mark. So what question mark does is this matches a single character. So any character can be in this pattern. So it can be a T, it can be a J. So it would match both resolvers that are TypeScript files and resolvers that are JavaScript files. So even when I build my project now, I still am able to find the resolvers. And then here I'm just mapping through each resolver. I'm requiring it. And then how I did it, if we look at one of them, the resolvers here, I exported a const called resolvers. So that's why I have .resolvers at the end there to require. I'm just grabbing that. And then we merge them together. So that is how I am doing the creating of the schema now. And now I'll show you what this allows me to do. So here's the folder structure over here. Let me just zoom in a couple times. So now I have a folder called modules, and inside of that I have user. So now as I have more modules, I can just add more folders. And inside of user I have all of these now. And I can click on register and we can take a look at what the schema looks like. So now all I have is the type mutation, and then this error is just coming from a different GraphQL file. And actually where I'm storing that is in a folder called shared, and I just have error.graphql here, and then I also have user.graphql. So I'm kind of just having any kind of shared GraphQL in this folder here. And this is something I can move around. If, for example, other modules need these, I can move it higher up in the structure, and I don't have to change this file because it's not importing it relative, right? It's basically looking for this globally. But yeah, so this allowed me to basically make my folder structure any way I want to. In this case, I nested it a little bit more, and it was able to find it and handle it. So yeah, so those are the changes that I made to make create schema a little bit more flexible, or generate schema. And yeah, I'm going to probably make one last change to this, and then I'm going to be basically good to go. At least I'm going to be pretty happy with it to start a project with this boilerplate.